Challenge number 3. So in this video I'm going to explain some programming concepts that you need to be able to understand to solve this challenge. So let's see what these are. If you scroll down past this, I'll explain this the last. So there is this concept of variables. Okay. So just like in mathematics, you can try to solve a problem and you can say things like let x be something. Okay. In programming, you can do that as well. You can store values, you can store data information in memory, and we do that using variables. So let's say you want to store the name of a person. So let's say it's Alice Bob. Okay. This is how you define a variable. You give its name, say equal sign, and its value. Okay. Let's say I say age equal to 17. Okay. Just a number, you assign it to this variable here. And you can start to do some interesting things once you store values like this. So one thing you can do is display the value itself. So I can say print name, and if I run this program, it's going to ask me to save it. So you can see here we have Alice Bob. Okay. If I also print the age, it's going to print 17 as well. So it doesn't print these alphabets like AGE, but since it knows that this is a name of a variable we've assigned here, it's going to print the values. So what if we want to try to print something that we haven't defined? So let's say first name. Then we are going to get an error here, like what are you trying to do? You have not defined that variable. Okay. But if we define it, so let's say we define it here, first name to be Alice, then we can print it just like that. Alright, so what kind of information, what kind of data we can store in these variables? So for one, you've seen here we can store like a string. This is we call in programming call this string, which is just text. Okay, it can be a name, it can be a city, it can be anything. Okay, I can define like a school here and say this is Loyola. Okay, a text like this, and every time you define a text, it has to be between these quotation marks. It can be double quotation or single quotation. So they both work in Python. In other programming languages, those two are used for different things, but in Python, either one is fine. So like I can define Loyola to use single quotation, so apostrophes like this, and I can print school, and you'll see this is the first print, so it will be the first thing to be printed, then this, then age, then the first name. So you can see school, Alice Bob, 17, Alice. Okay, so text is one of the things you can store. We've seen age here, which is a number. It's an integer, a whole number. You can also store some decimal numbers, like let's say GPA of 4.9. Okay, and we can print the value of GPA, and you will see it is 4.9 here. So you can store integers, you can store decimal places, decimal numbers, which are also like they contain fractions, just like this. Okay. Something else that you can store is something called Boolean value. and by Boolean I mean like this. So okay, a Boolean value is something that can either be true or it can be false. So this value of true or value of false is what we mean when we say a Boolean value. So we will shortly see how useful this is, because in most cases in programming we want to be able to make decisions. We want to be able to ask questions like can this person drive, like is this person above 18, or are you in A level, are you in O level, are you a boy, are you a girl, things like those. And all of those questions, they're like yes no questions. So if it is a yes, that is true, you are a boy, for instance. If you're not a boy, then it is false. If you ask, are you in a Loyola student, if you are really a Loyola student, it is true. That statement is going to result into true, and if you're not, it's going to be false for now. So that is one kind. Another kind, we will see this more of this later in this video maybe. So numbers, text. I think that's enough for this challenge. But something else that you can do is we can modify the values here, and perhaps one of the useful things you can do is activate this variables panel here. And what this is every time you run your program, it's going to identify all the variables that you've defined here and their current values right here. And to see this in action, I'm going to do something called stepping into the code. So this is when you want to execute your program one line at a time. Okay, so you can go to run and then this debug current script, or you can just do Control F5. So it is going to show us that now now the program is ready to execute this line. So if I press F7 or I press this step into, it's going to show me how the program is actually evaluating this line. So it is going to look at the right hand side, see that it is a string, and then it's going to assign it to name. So after this line is done, you can see here one variable has been defined with this value. It is next line. It's going to check the right hand side, Loyola, assign it to school. You can see school here, and then it finds this print action here. So what is this? Print school. So it wants to evaluate this expression. It is going to check what is this school. It knows school from memory, so it's going to replace school with the value of school, so that is Loyola, and then it's going to print Loyola, and then you will see Loyola printed down here. So we are done with that statement. Next, it is this one, and the same story, 17, storing as 17, GPA 4.9 stored there, and then you're going to print GPA. Before it can print it, it has to look for the value of GPA. That is going to be 4.9. It's going to replace GPA with 4.9 and then print the value. Then you're going to see it down here like that. So etc. with the rest of the... So this is what the program does every time. But if you just press this run, it's going to do all that very quickly. If I just press that, it's going to do the rest of the remaining statements. Alright, so this is variables. You have data, you assign it to a variable. Now let me show you some few operations that are going to be useful also to know. So let's say I want to define a variable called first name. Say it's Alice. I'll say middle name, it's Bob, and last name, it's Catherine. Okay. One of the things you can do with variables is combine them, and you can only combine variables of the same type. So like here, all these are string. By type I mean the kind of value that they store. So they all store strings here. If I just run this, see the values here, nothing here because I'm not printing anything. So they all store strings, so I can combine them. And let's say I want to also define another variable called name. This name is going to be a combination of first name plus middle name plus last name, and then I want to print this name. Okay, so let's see. So if we print, we're going to see it's Alice, Bob, Catherine. Something is wrong here. How come there is no space between these names? Okay, so programming is just going to do exactly the instruction you asked it to do. So you asked to combine these names, but you did not ask it to add space between these names. So if you want space between these names, you have to add the space yourself. So I can do that like this. Okay, I'm going to add one space there, and here I'm going to add space as well. Now when I run this, I'm going to have space like that. The name is going to have that value. I have 4 variables like this. So you can combine strings like this. Okay, very simple. What about numbers? So let's say we have A, we define A to be 4. Okay, and I define B to be 3. And I want C, and the value of C is going to be A plus B, and then I'm going to print the value of C. So simple. I have my variable A with a value of 4, variable B with a value of 3, and I define another variable C that is going to contain the value of A plus the value of B. So of course C is going to have a value of 7. Say print C. Okay, and we can see the program is tracking all these variables here. And remember, you get this panel if you go to view and you make sure it is ticked like this. Okay, if these are numbers, then plus we know is not the only operation we can have. We can have subtraction like that, and 4 minus 3 is 1, of course. Multiplication, which is not x, it is a star like that. We have 12, and division, 4 divided by 3, and we have 1.333. Okay, so we have addition, we have product, and subtraction, division. And this time I'm going to print more than one variable at once, like that. And of course here plus we also have subtraction. So, there you go. So yes, of course you can print more than one variable at once, and you can see it is 7, 12, and 1.333 for plus, product, and division. So these are numbers. If this was like 3.3, can you combine integers with decimals? Of course you can. And you can see here we have 7.3, If you add them, if you multiply, we get 13.2. If you divide, 1.2, etc. What if I want to combine numbers and text? Like, let's say I want to create my password here, and I want my password to contain my first name. Not very secure. Please don't create your passwords like that. But here I just want first name plus the value of A, the value of B. Let's say something like that. I want my password to be my first name, the value of B, and let's say this sign here. Okay, those two signs. Very complicated password, or not. So this is text, that's why it has quotation marks there. Then numbers, this is a number, it's a decimal number, and then this is text as well, it has quotation marks. So I'm combining text and numbers. So can we do this? Oh no. And Python is complaining here that you cannot combine numbers with text, just like that. Okay. But I really want to do this. Like, how can I do it? So remember, you can only combine variables or data of the same type. So one thing you can do is to convert this number into text, and we can do that by using this str action or function. So if you say like str and then you put your number inside, or you put the variable that contains the number, then it's going to convert that number to text. And if I run it now, it's going to be like, yay, we can do that. So we have our password, but we are not printing it. We can see it in memory that it is right here. But if you want that to be displayed here, we can do something like this. My password is, and then I say password, separated by comma here. Okay. If you want to print multiple things, you separate them by comma. And you can see it, say my password is Alice 3.3%. So that is about variables. So if you can go back to the challenge now, we can see here we have 4 variables. We have the screen height, the screen width, the ball size, and the wall size. So if we run this program, you can see this window here, and it is going to have like some height and width. And if I run it again, you can see the size of the ball. That is going to be the same as the ball size here, the diameter of the ball, and this distance from here up to here, the distance of this wall, the thickness of this wall, is what the wall size is. Okay, so they are just 4 values we are tracking here. And the reason I'm storing like screen height like this is because we are going to use it in a number of places. So every time you use the same value over and over again, it is a good programming practice to put it in a variable. Next we have this another variable here. We know it is a variable because it has the similar thing as a name, equal sign, and some expression here. So what is this about? So this variable here stores like some special kind of data or construct we call an object. So an object is more than a value like this. It's more of a collection of values and actions that you can do on those values. So for instance, this window here, can see this window here. It has several properties or several values. It has the width, it has the height. It can have like a background image. It can have a title, like here. So we've assigned a title here, and other things as well. So this window is one thing, but it contains a lot of data or a lot of information, and that is what objects are. They are just like a collection of related information treated as one thing. So here you can see we have so many things, but they are all called, like, they are all part of the window, so they are all one thing window. And objects also define some actions that you can do on the data. Like this title here, you can assign the title, you can assign the width, you can assign the height, you can assign the background. So you can do various actions on this object called window, and the collection of those values and the actions together is what we call an object. So in this challenge we are going to use two objects. We are going to use the screen object, that is going to be the window on which you are going to draw the rest of the things. And also we are going to define this turtle object, and we are going to call it a ball. So these two objects. So let me explain one at a time. So the screen, the way you define an object here, you call its name of its type, which is a screen, and you put this open and closing brackets. So that's how you define an object. And once we have an object defined inside this variable here, from this point onwards, the way we can refer to this window is by referring it to this screen variable here. So this screen refers to this window, everything. So we can start to call different actions that are related to this screen. Like one action is called setup. This setup action sets up the defines the width and the height of the window, which are these values we've defined here. So if we make this to be like 300, you can see it's going to be like tiny window here. You can still resize it, no problem, but we just want it to be 600. That's the value we are going with. Width, height. So this is what this setup function does. This function of tracer, this is the function that tells this window that we do not want you to update automatically, but we want to update manually. So we are going to tell you exactly when you are going to update. And by update, I mean make changes when objects move or objects change color or they change size. The window has to update. Like if a ball was here and it has moved to a different location, then we have to repaint the window. We have to clear the screen and then put the background and put the ball in a new location. So that is what we mean by update. So this tracer function, if you pass it with a value of 0, is telling the program to stop updating automatically, and we are going to update manually when we want. We are going to do that here. And the reason this is important is because you want to exactly control how many times the window updates per second. So you want to control that. We don't want Python to do that automatically. Another action we can have is assign the title. We just put screen.title here, and we can pass in whatever thing you want, and this is what will be displayed here. So of course you need to update it with your name here. So if it was Alice Bob solving the problem, could have done it like that, and we have solved by Alice Bob. Okay, and I will close this variable panel here. We don't need it for now. The next action is on the screen window is to assign the background image. So we have the background image as background.gif. It's already provided for you, just this one. Okay. So that is the last action on the screen. So as I said before, the next object you are going to have, the second of the two objects you're going to have, is the turtle object. So this is a way of quickly drawing, one way of drawing shapes, and the shape you're going to draw here is a circle. So you can have other ones as well, like a triangle. If we have a triangle here, you can see it's that shape. If we have it as a square, we can have a square there, and you can also have the turtle object, and we have our turtle there. But for this problem, we are going to define the shape of, we're going to use the shape of a circle, like that. So since this is an object, it has data and some actions. So one of the actions is we can assign the speed of this object, the object we call ball. So if you remember from the first from the reference I provided, if you assign this, you can call an action speed and assign anything from 0 to 10. If you assign a number from 1 to 10, 1 is slowest, 10 is fastest. If you assign it a value of 0, you just ask the program to move this object as fast as it can. Okay. Next, we call this action of pen up, and you remember from the first challenge, this is when you want to move the pen without drawing anything. So just pen up. The next action is to define the shape of this turtle object, and we already seen several of these, and we are going with a circle. Next, we define the color. So we have red, and we have a reference. You can refer to the reference as well. You can use, if you have green, it's going to be green, but we want red, so we are going with red. And next is turtle size. So if you say you pass a value of 1, that is the default size, you can see how small it is, and then you can put how many times you want above the default size. So if you say 10, that is you want 10 times the default size. You can see. Ooh. But you are going with 2, you just want twice as big. Okay. So that is the end of these different actions that we've assigned in this ball. Okay. These actions have already been defined inside this turtle object. Strictly speaking, it's called a class, but consider that as an object for now. So within this turtle object, they are all it defines all these different actions. So we are just using them here. But beyond the actions or the values that come by default, you can add your own actions, you can add your own variables. So just like how you can define like something like speed equals 67, for instance, this variable is just outside anything, it's just by itself. The same way we define this, they're just variables that are not related with anything else. But if you want to define a variable within or inside this ball object, this is what you do. You say ball dot the variable name and its value as usual. So here I'm defining the speed x, how much in every every time how much do we want the ball to move along X and how much do we want the ball to move along Y. So these are the two variables I'm defining as part of the ball object. Okay. So next we have this while true segment. So what is this about? So probably I need to explain this better here. So let's say I want to print like 20 numbers. I want to print, or let's say 10. I want to print all the numbers from 1 to 10. So one thing you can do is just to do like this: print 1, print 2, print 3, etc., all the way to print 10. And if you run this, you're going to see like 1, 2, 3. But if you repeat this 10 times, you're going to print all the numbers up to 10. But this is not like the effective way to do this, because imagine if you want to print like 1,000,000 numbers. Probably you're not going to write 1,000,000 lines of code just to do something like that. So here's where loops come in. So the structure that we need is what we call a loop, and there are two kinds of loops. There is a for loop and there is a while loop. They all can do exactly the same thing. So whatever you can do with a for loop, you can do with a while loop. So they are equivalent in what they can do. So in this challenge you're going to see the while loop, and later on we'll jump into for loop. So while loop. So what we can do is we can do something like this. We can give the value of X equal to 1, and then we can say while X is less or equal to 10, print the value of X, and then after you print, increment the value of X by 1. So take the current value of X, add 1, the results, put them back to X. And I'm going to activate the variables here so that you can see what is happening. So if I run this, you're going to see here all the values have been printed from 1 to 10. So let's see this in action. I'm going to step but in a fast way. So this expression here, X equal to 1. After this, we define a variable X with a value of 1. We've already seen that. And then we see this line while X is less or equal to 10. So this part here is what is called a condition. Okay. Everything that is inside this loop, and the way you can tell that is with the indentation here, this space which is left from here to here is a must. So if you do this, I have to stop first. If you press enter here, it's going to indent automatically. So everything you put with the indentation is going to be part of this while loop. Meaning if you put something outside, like here, like we can put something like done. This is going to be executed after this segment here. So you can see it's executed only once. But if you put something inside, like yes, like this, as part of the loop, this is going to be executed every time. So back to this. this expression gives x. Here, every time before it can execute this loop, it's going to test this condition. If this condition is true, it's going to enter and execute the lines of code that are inside the loop. If the condition is false, it's going to quit and go to the next thing after the loop, which is this line right here. So at the moment the value of x is 1. So is 1 less or equal to 10? It's this expression here. Is 1 I have to stop that one first. Is this expression true or false? Is the value of 1 less or equal to 10? That is true. So since this expression is true, then you are going to execute the loop. So I have to repeat this again. So it has printed 1, and then it is evaluating this segment here, which is x plus 1, and you can see the value of x now is 2, and then it's going to go back again and check the condition. Is the current value of x less or equal to 10? Is 2 less or equal to 10? Is still true. It's going to execute the body of the loop. It's going to print. It's going to increment the value of x by 1. The x is now 3. It's going to repeat that until you reach 10. So let's see what happens when you print 10. It's going to increment the value of x. The value of x is now 11. Is 11 less or equal to 10? That statement is false because 11 is of course greater than 10. So since this condition is false, it is not going to execute to enter into the body of the loop. So it's going to exit the loop like that, and it's going to jump all the way and execute the next statement after the loop, which is to print the statement done. Done. So that's what a loop is about in a nutshell. So if we come here, we can now see clearly that we have a loop here, and we have the condition which is not changing because we just have true here, and this is because we want our simulation to continue running, as long as the user wants, until the window is closed. So if we run this window will continue being here as long as the user wants, until you press that close. Alright, so inside this loop, these instructions are going to be executed over and over again every time. So what is inside here? So the first thing we see is time.sleep and then some numbers. This is an action that comes from this library here. Okay, I said I'll explain this last. So these are libraries. So some people have, some programmers have created some code, some functionalities, some variables, some actions, and they have categorized them into different things. So Turtle is for graphics. Time has things like time-related actions. So one of the time-related actions is to pause your program. So sometimes, like if I remove this, if I comment it out, I run, you will see you don't even see the ball, because you can see like it just jumps very fast. So we want to be able to slow down our program so that we can see the ball moving slowly like that. So this is where sleep comes in. It just pauses the program, makes the program goes to sleep for this amount of seconds. So since this is 0.01, these are like 10 milliseconds. Okay. And then we have screen.update. Screen.update paints the window again. So without this the window will not, because you remember I said we disabled automatic updates here so that we can manually update ourselves, and here's where we update. So if you call the update action on a window, you're telling the window now if anything changed, just repaint the entire window again. So it's going to add everything, the background, all the balls and other objects you've added. And then next here I define two variables, current x, current y, and these temporarily here are going to store the current location of the ball, so the x coordinate and the y coordinate, and this is how you can get the current position of the ball, the x and the y. And then using these current values, I calculate the next position of the ball. So I take the current value, I add the amount of change I want along x and the amount of change I want along y. Remember, that is what the speed is, just how much it's going to change horizontally and how much is going to change vertically. Okay. And then after this, I assign these new values as the new position of the ball using this action set x and set y. So after this, the ball now is going to have a new location. And then remember, once this is done, there's nothing else to execute. It's going to go back, the condition is still true, so it's going to pause for a little while and then it's going to update. And when it does update this time, it's going to paint the ball in the new location, the location that we've just calculated here. And as a result, you're going to have it moving like that. So let me put this here and run it so that you can see exactly what is going on. So one line at a time like that is going. You can see after you define the window will be there. You set up the width and the height. It's going to have the respective width and the height, and notice the title is the default title, but after this has assigned the title, but since we deactivated the manual updates here, the update will not happen until you reach this point. This has assigned the background, and all these parts are going to paint the ball, but you won't see anything until you update. Assign the speed, and then we enter the loop now. So we pause for like 10 milliseconds, and then this action is going to update the window, and you see everything now is here. Okay, and then we calculate the next value of x and y. We get the current values of x and y, which is this position here, and then we calculate the next position both along x and along y, and then we set the two positions for the ball, and then we go back to the beginning. And notice the ball, what is going to happen after you update here. See, it has moved a little bit. So every time the update is called, the ball is going to move. So this is what happens every time. These instructions are going to be run over and over again. And when normally the program runs by itself, this happens very fast. That's why you see like the ball is moving very fast like that, very smoothly. But notice every time you run update, the ball moves. Okay. And if I just run everything, you see it's going. So you can understand what is going on now. So your objective now is to make sure the ball bounces. So when it reaches this point here, okay, when it is trying to go out of the window, it has to bounce and go like that, bounce, just keep doing that. Okay, something like that. And let's say, and you're going to add your code here. Just few lines of code should be able to fix that. And the structure that is going to help you do that is called a branching or if statements. So what do I mean? Let's say we have age here equal to 710. Okay, and then imagine you want to be able to tell the person if can drive or not. If the person is at least 18, they can drive. If they are less than 18 years, they cannot drive. So in programming, we have this structure called if statement. So if we say something like if age is greater or equal to 18, okay, I don't need the brackets because it is only one condition. If the age is greater or equal to 18, we want to say you can drive. Okay, and then otherwise, else, say you cannot drive. So what is this? The program is going to evaluate the value of age. If it is greater and equal to 18, it's going to print this. Otherwise, meaning if age is less than 18, it's going to print you cannot drive. So if we have, since we have 17 here, I will run one line at a time. We have the value of 17. It's going to evaluate this. This statement is false. Okay, so since it is false, it is going to jump and print this. You cannot drive. You cannot drive, like that. But what if someone is like 43? So if you are 43, then the value of age is now 43. And then this statement is true. Okay, and then it's going to run this one. You can drive. And you see you can drive. So this is what branching means. The code is going to execute different, is going to take different actions depending on condition you put here. So you can test for things. You can imagine in the future we can check, like let's say you want to open a file, and then you can check, does the file exist? If it exists, you're going to open it. If it doesn't exist, maybe you can tell the user, hey, you're trying to open a file that does not exist. Or if a user is trying to move a file, is trying to delete a file, or you want to do, as long as you want to take a certain kind of action depending on whether something is true or false, and a different kind of action depending on whether it is true or false. That is a branching if statement. So you can imagine for this program now, all you need to do is keep on checking the position of the ball, and once the position of the ball is outside the window here, then you need to correct. So that is going to be your challenge, because if I'm going to explain more, I'm going to give you the answer. But just think about it and try to see if you can correct the direction the ball is going by adjusting some of these variables, like the speed and the location and all that. So all the best.